So welcome once again. This is the lecture number 9 of the deep learning course. In this session, we are going to talk about the neural networks. I would start my discussion by going with a small recap that we have done in the last class, and then I would try to develop the concept that why we need a neural network and why into this different kind of scenarios neural networks means having more than one neurons are going to be more effective. In the last class, we have seen that if we have a perceptron that has a weight minus 30, 20, and 20 with respect to the two input, which are x1 and x2, with the satellite input x0 that is plus 1, we have seen that if we provide 0, 0, we got output as a 0. We provide input 0, 1, we get output as 0. 1, 0, it is 0, and 1, 1, it is 1. So in this kind of setting, you can see that this particular table means the behavior of this particular neuron or perceptron looks like as a AND gate. Looks like as a AND gate. And we have seen also into the last class that a different kind of weights where I say that W0 is equal to instead of minus 30, if it is minus 10, then the circuit that we are going to get is going to give 1 in both the places, and therefore it becomes logical ART circuit. If there is no second input and this particular value is changed to 10 and this is minus 20, so we have seen that with the 10 and minus 20 this becomes a NOT gate. Essentially what we have seen that we can make AND, OR and NOT, both the gates. And if you want to be more cautious, you can say that using AND and OR circuit you can make a NAND gate, and any NAND gate is very general, and therefore any kind of logical circuit, if you want to simulate, if you come up with any kind of Boolean logic circuit with some kind of input, you can decide a circuit using only these perceptron over here there that can give you the same output. This is a very interesting observation in the terms that if you explore more of the complexity theory into the complexity theory, you know that there are multiple proofs available that actually says that any problem, any prime problem can be converted to a logical circuit. And then it says that based on the circuit theory only it provides that the whether the problem is NP complete or what kind, or can you find out the solution of those problems or not. So if you can convert these kind of things to a circuits means what, that you can model any kind of problem using these kind of circuits. Okay, that's why they brings lot of power to your system. Let us see one more example, and here I think this is not the example, this is just the interpretation of the thing that we have seen that this was the perceptron, then this is the equation of the perceptron, minus 30 plus x1 multiplied by 20 x2 multiplied by 30. It is an equation of line. If you plot this equation of line somewhere, what happens that one side, if anything is greater than this, becomes a positive thing, otherwise the things which are below this, they are negative things. So therefore any perceptron which is a linear decision boundary actually divide the space into the two parts, and one part is actually positive and another part is negative. We have seen this multiple number of times. Now let me ask you the question, can you design a perceptron for this kind of table? I have a specific table where for the 0, 0 I want 0, 0, 1 I want 0, 1, 0 I want 1, and 1, 1 I want 0. Can you design a perceptron for me? So how can you proceed? So you can proceed in this way, that let's assume that there is a perceptron and it has, since two inputs are there, x1 and x2, and I can say that x0 is equal to 1. I don't know, so let me say that weights are w0, w1 and w2, and then there is an output. So for this particular input, what is going to be, you can see that what the equation of this particular thing says, it is w0 plus w1 x1 plus w2 x2 is equal to 0. This is the equation that it represents. And for this 0, 0, it should give 0, means 0, 0, when you put this value as 0, this value as 0, it means that w0 should be less than 0. This is what the condition you get from this equation. If you consider the second one, it says that w0 plus w1 into 0 plus w1 into 1, and this quantity, what is this particular quantity? Because this vanishes, it becomes w0 plus w1 is less than 0, because you need 0 over here. This is the second condition, two conditions. Let us see the third one. It says that w0 plus w1 x1 plus x1 is 1. Let me just quickly write 1 multiplied by 1 plus w2 into 0. So, and since you need the output as equal 1, so it should be greater than 0. So this vanishes. It gives you what? W0 plus W1 should be greater than 0. This is the third condition. Okay. And from the final fourth one, what is the fourth equation? 1, 1 means what? If you put into this particular equation, you can W0 plus x1 plus x2 is less than 0. Am I right? These are the four equations you can create out of this particular equation. So if you create these four equations, let me remove everything else and put it into this particular way. So can you give me some value so that this particular thing is satisfied? I think it is W0, okay, W0 plus W1. So can you give me an equation that can satisfy this thing? So W0 should be 0. So you can take W0 is equal to minus 20. Okay. W0 plus W1 is less than 0. So you can take W1 is equal to minus 5, minus 10 or whatever value. So that their summation is again less than this. W1 plus W0 plus W1 is greater than 0. So this third equation W0 plus W1, can you suggest any value of W1? Because W0 is equal to minus 20. If you add something, it becomes to be like that. So you can put W1 is equal to, I think it should be greater than 20. So can I put it 30? Can I put it 30? Am I right? Yes?
Yes, sir.
So in the using the third equation, W0 is equal to minus 20 plus x1 is equal W, why I put x1, W1, W2 plus W1. What is the value of W1? W1 is equal to 30 plus W2 is equal to minus 10. It should be less than 0. So I'm right. This condition is actually verified. It is correct. So I need not to have any problem. So this is going to be one solution for this thing. So you have designed this into this particular way. You say that this is minus 20 and W1 is what? Minus 10. And similarly you can say that W2 is equal to 30. Am I right? What I have done? I think I have done some mistake.
So
Okay,
W2 should be minus 10 and then will be 5.
yeah. Let us go into this particular thing. So these are the four equations that we have come up with. Okay, the first equation says that W0 should be less than 0. So can I take W0 is equal to minus 1? The same solution is written over here. Instead of minus 10 and minus 1, it is there. By the second equation, here W0 plus W2, W0 plus W2 should be less than 0. So I have taken W2 is equal to minus 1. Into the third equation, you can say that W0 plus W1x plus W2 into 0 should be greater than 0. So the W1 should be, I can take, let's assume W1 is equal to 1.5. So this equation is also satisfied. Third equation, where this summation should be less than 0. If you put these values, it actually satisfied. So what is your solution? Your solution is W0 is equal to 1, W2 is equal to minus 1, W1 is equal to 1.5. By this, you can say that these are the values which are actually correct for me. There is no problem in doing any kind of multiplication. Minus 10, and 15 also is a perfect number. You can put it here. W0 is equal to minus 10, W1 is equal to 15, and W2 is equal to minus 10. So by this, you have created this. Makes sense? This is the second way of doing the same thing, that you have solved the equation. Okay. Definitely other possibilities are also there. Instead of 1, you multiply with any kind of number over here. So the different solutions are there. You can generate multiple solutions out of that. So this we have discussed earlier also, that let's assume that here are say negative example, here are the positive example. In all the cases, what is going to be possible, that this line, this line, this line, this line, this line, this line, multiple lines are actually possible. Okay, in all the scenarios, multiple lines are possible. So this is not going to be a big thing. Multiple equations are possible. We are not going to find out the most fat one that actually SVM finds out. We are not actually doing that thing right now. This is another example. I think it is the same example where I am going to tell you that give me this. neural network for this. So now you have a kind of freedom that you can select something. So please see this, what I'm going to tell right now. Few minutes back, how I have solved this particular problem, I have written the different equations. But now I am telling that can I write like this? You know that x1 and x2 are these values. What is x2 bar? What is x2 bar? x2 bar is 0 becomes 1, 1 becomes 0, 0 becomes 1, 1 becomes 0. So 1, 0, 1, 1. If I take AND of this quantity and this quantity, x1 and x2 bar. So since here is 1 and AND gives 1 at the places when both have the 1, so you are going to get 1 here. All other places there is 0. So this is the thing that actually we wanted to get. This is the thing that we wanted to get. Okay, the classification, this is the same classification we wanted. So what it says, that take the x1, take the x1, take the x2, and you convert it to the x2 bar. How can you convert this to the x2 bar? You know that if you want to convert it to the x2 bar, you apply a weight of minus 10 with the with the weight what? 10, 20. Can we go back and see once again? Here on this particular slide, we have actually discussed the same thing. Okay? Yeah. 10 and minus 20. W0 is equal to 10 and this is minus 20. So we can apply the same thing over here without any problem. So what was there? 10 and minus 20. Okay. When it is 0, it is 10, it becomes 1. When it is 0, the equation is what is the equation? 10 minus 20x is equal to 0. When x is equal to 0, this equation becomes what? 10. It becomes 10. So positive and 1. With the 0, it gives 1. When the x is equal to 1, this equation becomes minus 10 and therefore it becomes negative and gives you what? 0. So this is how we created what? Not gate. And then if you have created not gate, then you need to apply a AND gate. How to apply a AND gate? AND gate needs what? That the same thing. What was the particular architecture? Minus 30. Let me just go on the particular side once again to give you the same thing. What was this? Minus 30, 20 and 20. So minus 30, 20 and 20. Okay. So minus 30, 20 and 20. This is how you create the circuit. Is it clear? Correct? Any problem in that? With x1 and x2 as input, with these kind of weights available, your network is going to give this output, which actually I wanted here. And few minutes back, we have seen that if you find out this thing, a single perceptron can also work into the same way. So instead of single one, you can apply two also, and they are also going to give you the same output. Make sense or not? Do you understand this? So you sometimes you may think that why I am going to put two things. It will be better that I put only one thing. Na? So this is how the same architecture is being you can write that x1 and x2 are there, and then you combine x and x2 are there. Here you combine them as a knot, and then after knot you are going to combine them, and you are going to get the output. However, in this kind of circuit, you can see that there is one layer here, and input from here is going to cross from this layer to this layer. Mostly with this kind, we avoid this kind of architecture because training this kind of architecture is not that easy. Okay, mostly we avoid this kind of architecture. Okay, So I have shown you that if you want to make this thing, so if possible, if the data is linearly separable, you can also design a single perceptron for that, or you can divide a neural network for that. Neural network are actually, I can extend this idea and I can tell you, neural network are something that where you are actually multiple layers, and in every layer you are going to put the neurons over there, and then you are going to get the output. I am telling first time to you, so you may have some confusions of why we are going to have it, why we are going to have this kind of architecture, what is the advantage of this particular architecture. So we are going to talk it into more detail very soon. But right now I wanted to tell you something, that whenever we actually say that it is going to be a neural network and we are going to deploy the things into layers. So into one layer, if there is any perceptron, it is being connected, its output is sent to all the other things which are there into the, all the perceptrons which are there into the next one. And it is getting input from all the neurons which are there into the previous layer. So this connection is going to be a dense connection for all of them. Is it clear? Neural network, whenever we want to neural network in general, there are layers, and one last layer we can call it output layer. First layer we call it as an input layer. These layers are called the hidden layers because from the operation perspective, you see that something you are going to provide in and something you are taking out. So these things are only known to you, that how many values you are going to provide, how many values you are going to in. Inside there could be more number of neurons, and how many number of layers could be there, it depends upon your problem and your solution. So sometimes it is not that much clear that how many neurons are there, but you try to adjust them into some logical way. What is the logic? We are going to talk about very soon. Okay. Depending upon your requirement, number of layers may differ. Number of layers may differ. Nodes in each intermediate layers may differ. Multiple output neurons are used for the different classes. Here, what is this? How many classes we have? If we have five number of classes there, so mostly into the output layer we put four things. The four number of things over there. For example, Cipher 10 database. You know that CIFER10 database. In Cipher 10 database, how many classes are there? 10 classes are there. So if you are designing a classifier for Cipher 10, so how many neurons are needed into output layer? 10. 10 such things will be needed. So what is the output corresponding to each of them are going to signify? They are going to signify that what is the probability that the input that you have provided is going to have that particular class. So sometimes if you want to maintain this kind of notion, the summation of all these quantity should be one. Summation should be one. Summation of all these, all the output is going should be one. So there is a notion called softmax you actually apply at this particular place, and actually it ensures that whatever the output that you are going to get is going to be, summation is going to be one. And sometimes, if for example, if there are multiple values and you want to pick the highest one, because if something you feed over here, so you want to find out that what is the which particular class this particular item is. So you would like to see that which particular neuron or which particular output is going to have the highest value. So you want to increase that particular thing more, stand out as compared to others. So there is one layer, softmax layer, that actually tells that with respect to every value, let's assume that there are 10 values, v1, v2, v3, dot 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 v10. 10 values are there. So you convert this, software convert this to e to the power v1 divided by summation of e to the power v1. What is the summation of e to the power v? It is going to be e to the power v1 plus e to the power v2 plus dot 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 e to the power v10. 10 values are there. So if this summation is going to be divided, so for first value is converted to e to the power v1 divided by this summation, second value is also e to the power v2 divided by this summation, and so on. So the summation, if you find out the summation of all these quantity, it becomes 1, because ultimately over you at the denominator you are going to see that term by term summation, and in the numerator the same value is going to come. So ultimately the value summation is going to be 1. So this is needed. Okay. So multiple output neurons are used for the different classes. Two-level deep neural network can represent any Boolean function. So hope this line that we have actually seen earlier should be clear to you. How can it should be clear to you? That, as I told you, that if you come up with any kind of circuit, so the circuit would be something like that. Not sure about this x, any Boolean circuit, any Boolean function if you come up. So I just write any Boolean function if you come up with some kind of variable x1 x2 dot dot any kind of variable, you can always convert to SOP form or POS form. What is SOP or POS form? Where sum of product. SOP form is sum of products, where you say that x1 x2 bar x3 kind of thing plus something plus another term plus another term. So you can, any Boolean function can be converted to the SOP and POS form. I will not go to that particular proof. It's not required at our level. But you know that any Boolean function can be converted to SOAP or PAR form. If this is the thing, then you pick any of them. For example, this, what is this? And so you put a neuron over here and you connect this with the appropriate weight so that here and is generated. Okay, out of them and is generated. So for all the literals you can create over here, and you create you deploy one uh, perceptron for each of them. After that, what is needed? You have to apply R, because it is a summation is going to be R. So one neuron with the R of all these values, your task is done. You need not to have these things. Okay, two layers is sufficient to actually, two layers is sufficient to represent any kind of Boolean function. This is what the general idea. Now I have an example for you. Okay, so this is the example of where these are the positive green points, and this is the red point. Note that this is the red point. So can you tell me that, can you draw a line that can segregate all the green points with the red point? Yes or no?
No, sir.
No. So if I want to develop a classifier for this kind of system, so how can I go ahead with that? Question is, can I use a perceptron? Can I use a perceptron? When I'm asking about the perceptron, I'm asking about a single perceptron. I have one perceptron. I want to use one perceptron for solving this thing. Answer is no, because one perceptron is going to represent a line. If this is the line, these points are bad. If this is the line, again these points are bad. If this is the line, these points are bad. Again, this point is also bad. If this is the line, these points are bad. You cannot draw a single line. However, you can draw multiple lines. What do I mean by this? You draw a line like this. Okay, you draw a line like this. You draw a line like this. You draw a line like this. 3 lines you draw. And now you represent maybe these lines could be represented using some colors also. You can say that line number 1, line number 2, and line number 3. This area, if I ask about this area, okay, this is above 2, above 3, and below 1. So I can say that 1, can I write like this? 1 bar 2 3. This area is 1 bar 2 3. Yes or no? 1 bar means below 1, 2 means above 2. Can I write like this? Yes. So
Yes, sir.
tell me that what is this area? 1. This area is 1 2 3.
1, 2, 3.
Okay. So help me to find out this area.
So 2 bar 1 3 or 1 2 bar 3.
1 2 bar 3. Similarly, what is this area?
So that would be 1 bar, 2 bar. No, sorry, 1 bar, 3 bar, 2. Or 1, 2, 1 bar, 2, 3 bar.
2, 3 bar. Similarly, you can find out this area, and this area also. Okay. So what I was telling, that you actually draw 3 lines. Okay. And now you can segregate the point where actually you know that this place is what? This place is black, this place is red, all other places are actually green. So you can represent this thing into a table. So maybe this table you would be very easy to understand. 0, 0, 0 below all the lines, below here, below here, below here. So this is the area, and here what is the color? One. Color is one. One it is green. Yes. 0, 0, 1. Red, blue, and black. So 0, 0 means below red, below blue, and 1 means above this. So this is the place. This is the place where we want what? 0. Is it clear to everybody? Similarly, all other places, if you investigate in this particular way, all other places you are going to put 1. So you can put 1, 0 somewhere else also. Some point can lie there also. There is no problem in that. Okay. So maybe somewhere if there is 0, no problem. Sometime it may be possible that there could generate a few other scenarios which are actually not possible. For example, 1, 1, 0 is not possible. Why not possible? 1, 2, 3, 4, 5, 6, 7. There are 7 other places now. So it is actually telling what? This particular thing is telling 1, 1 means red line below the red line. So below the red line you come into this particular area, and blue line, no, red line 1, sorry. Red line 1 means this area. Red line 1 is this area. Blue line 1 is this area. And black line 0. So black line 0 is this area. So there is no common area into this particular scenario. Can you see this? There is no common area into this particular scenario.
Yes.
So some absurd condition can also arrive, but we are not interested in this. We are interested into the possibilities, and out of this possibilities, we have actually classified all these things. Now I want to make a neural network out of this. So you know that. Can you make that whether this particular line is below this? That is very easy, because you can apply a you can allow a perceptron, and perceptron can find out the right parameter for you. So initially this is the input layer where I say that x1 and x2 are input, and this is what my bias is. And bias is nothing more. I have already told you, don't get confused with the bias term. Bias is just a fancy way to say something, that there is a weight where the input is 1. With the hidden layers, 3 lines are there. So with every line I am going to write this. For every line I am going to create a perceptron. So this perceptron is about maybe red line, this is about blue line, this is about black line. So what is the weight with respect to? You can find out what is the parameter. Using those parameters you can set up the weight. So this thing everybody can get. Yes or no? Till now, here you can find out the parameters. Don't think that automatic way of finding. Right now, just think that everything is given to you. Can you find out that what is the equation of this line, equation of this line, equation of this line? By this, you can set up the weights. Yes or no?
Yes, sir.
Yes. Yes. Now you need this particular scenario where this 0, 0, 1 is there. So again, you have to apply the right weight so that you can apply this AND logic, so that here should be 0, here should be 1, here should be 0 and 1. So you apply another logic using a different kind of perceptron, and then you get the output. Do you understand this? How come this particular circuit came? Based on your data, you have actually understood that looks like that 3 lines are sufficient to bound my area. So therefore you put 3 perceptrons over here, and then you have put 1 over there, but because you were thinking that this is going to be only one thing, one area. If multiple areas would be there, for example, if there red points were here also, so you need more lines for that. So you put more things over here, and you put things to find out whether the item is inside this or inside this, and then out of this you combine this thing over here. So you put more number of required perceptrons with respect to that. Once again, when you realize that what is your problem, and with respect to your problem you understood that looks like my problem is actually can be solved using 3 different lines, you put 3 perceptrons over here, and then you know that you can combine them using the AND logic, because only one line there is 0. So you put 1 over here. If there would 2 different places there would have been 0, you put 2 different things over here, find out what is the logic for that using those lines, and then you combine them as an output. So this is the idea behind the neural network, why you design a neural network, and what is the importance between them. You can by yourself see that upper layers are actually combining the data that is actually there on the onto the previous layers. So they actually represent the higher level constructs on the previous things. So initially you have the data, you get some understanding out of that, then you again apply some other understanding on that, then you apply some other higher level understanding on that, and you get your results. Neural networks based system are very common these days. You know that everywhere into deep learning we use neural network. It is appropriate for the problem with the following characteristic. Neural network you apply into when the problem has the following characteristics. Instances are provided by many attribute value pairs. Means it is going to be it is going to be a supervised learning setting where for every input you are going to provided that what is the output. Attribute value means what is the input, what is the input, what is the output. And many examples are there. Many such examples are there. Target function can be real valued or discrete or anything. That is not a big problem. Training example may contain error. So this is a very important thing. Sometimes it may be possible that this kind of network architecture can handle the errors as well. If the data has some kind of error, so it can handle those kind of things. Long training time is acceptable. That is a very important point. So what happens that if you are going to develop a neural network based system, so this architecture, the neural network architecture that you are going to make for the input and output pairs, it take long time to train because multiple iterations are needed. So we call it epochs. So multiple number of time you need to train. So it takes long time for the training. However, when the system is trained, given the input, with no time you get the output. So however, it takes long time for the training, but fast evaluation of the target function is required. Means immediately you want to take the decision. It doesn't take me any kind of computation to find out something, but just give the input, it passes through the network, and at the end you get the output. What is the output? So when you are going to develop the automated driving vehicle, at that time it is fine that you take 50 hours to train. But at the time when your car is running, immediately if you see something in front of your car should be able to apply the brakes within no time. So this system provides you something that evaluation is actually evaluation means given the input, it takes the gives you the classification in no time. However, training takes lot of time. Okay. Also, very important thing is this, that most of the time when you come up with some kind of if you have model, for example, if you have some model you have, and you are providing some feedback and getting the output, and let's assume that this model is mom. This is mom, okay, your mommy, and you are asking from the mommy that mom, I want to take chocolate. Okay, so mom is telling yes or no, yes or no to you. So mom is telling no, you don't take the chocolate. So what will you do? You would ask why you are actually not allowing me to take the chocolate. So this is the interpretability. Whenever the model is going to give you something, you want to find out that interpretation, that what is, why my system is going to tell me this. So most of the models that actually into the machine learning we see, they have interpretation, and a very good model is the, for example, the when you see the decision tree, it has a very high interpretability. But these neural network based system has a very low interpretability. They gives you yes or no, but the values, these fractional values, what do they mean? Many other times would we not be able to find out the meaning. So interpretability is an issue. Ability of humans to understand the learned target function is not important. If it is important, then going for the neural network is not that a good choice. You should go for the other things. Thanks all for, that's all for today. Thank you very